Hi, I'm Matt, and this is my garage. So the time has come to dial in the cams with the vernier pulleys, set the cam timing, and promise you guys I would film this. Got standard vernier pulleys. You can get them off the internet if you just search Lotus Esprit vernier pulleys. These will pop up. So I think first let me show you what you need to dial in the motor, and then we'll go over and we'll get started. So here's what we need to dial in the cams. Guys, like I always say, I'm not a master mechanic, I'm not a certified technician. So I do the best I can. Some of my tools are not the most expensive, but they get the job done. All right, here's what we got. Number one, dial indicator, right? That's what this is. Comes with this adjustable arm that you can lock off to make it tight, the dial, and a set of scripts. The one I got is from Grizzly. There you go. Seems pretty good. Haven't had any difficulties with it yet. The other thing you need is you need some extensions for your dial. So these didn't come with the dial, but I bought this little kit. Had it on probably Amazon. And they're just different extensions you can add on to there. We're going to need that when we go to try to find top dead center of the pistons, because they're so far down between the cam carriers, through the spark plug hole, onto the piston top. So we need some length, and that's how we're going to get it. And then you need a tip for these extensions. And I've got a little kit here. It's like $9. You know, it looks like 25 different possible extension tips here, or so that it can ride on top of the piston. And also, they're not going to damage the cam followers or the pistons. And then you need a dial wheel, right? And then you can buy these anywhere. I think I got this one from Jegs. Works pretty good, although this one's kind of big, right? There's not a lot of clearance on the motor to get this to turn around without interfering with something else, but it just barely works. All right, something else I had you pull together was just a short spacer here for my degree wheel, as I put it up against the pulleys. And I need a longer crankshaft bolt because I got to get through the depth of the pulleys that are on the crank. So I've got this bolt that goes through, it's a little longer. I got this spacer on the back to screw into the crankshaft, and then this will ride on the back of the pulley, give it some stability. I got a regular 104 cam gear here. Green dot on the X and intake, so be using that. Other than that, yeah, so let's get over to the engine and get started. Hey guys, real quick, before we get started with this, I don't want you to damage your motor. So up until now, the crankshaft has been rotated either 90 degrees before or 90 degrees after top dead center. That's where you want it going into this. So put your old cam sprockets on your camshafts and rotate both camshafts such that the timing marks are facing each other, adjacent to each other. Then when you have that, you can then move the crankshaft to top dead center, but only after you align the timing marks on the cam sprockets. And at that time, you could take your old sprockets off of the camshafts and install the vernier calipers, and that's what we're going to pick up with the first video. Dial wheel here. I've got a little wire up here, and it doesn't matter where that is, but I just need something to point to top dead center, and you'll see in a minute why. So before I do this, now what I've done is I've set the motor to top dead center. It's pretty close on there. It doesn't have to be exact. And then if you look up here on these vernier wheels, you want to set this up to begin with. So these are set up with the piston on top dead center of the compression stroke. I've basically taken some 104 wheels with the green dot. Here's the exhaust. You can see the keyway. Line up the keyway. So I know I made a little dot here. You can't see it. I know that's generally where the 104 degree is. And then I did the same on the intake. Of course, you turn this over, you go to the intake side, line that up, and I know generally my 104 green dot is there. What I struggled with is the key is here, but yet my 104 marks are around here. But if you look on the wheel, my gauges there and my increments are nowhere near the 104 mark, and that's okay. And it took me a while to figure this out, but that's fine. It doesn't matter where they are. What you do want to make sure is when you put the gear on, because it only goes one way, because you've got key in one location, just make sure the adjusting screws are in the middle of its range of motion. All right? Okay, so let's put the degree wheel on. Remember, I'm at top dead center. So I'm going to take my spacer. I'm going to put it in there. Put it over the degree wheel. All right, so I am going to just screw this on. Try to center it up the best I can. And then I want to, before I tighten it down, get my top dead center mark on the wheel lined up with my piece of wire here I have on the motor. Because that's what we're going to use to really dial in top dead center on this motor. Alright, so I've got that in there. Now I do need to crank it down here with the gun, because we're going to be turning it with the ratchet, and I don't want it to come loose. Alright, that's it. So, that turned my motor over a little bit. I'm going to go back now to top dead center. Alright, there we go. That's step one. Now we're going to go on to finding top dead center of the piston. Alright, here we go. Step two. We got to find top dead center. True top dead center. Not what the pulley shows. That's close, but it's not good enough for what we're doing. Alright, over here in the number 4 piston, I've got the dial gauge set up in there. And I've got some pressure down on the piston is generally all the way up at top dead center. But I still want to have the gauge register as the piston moves up or down. So I've got some tension already on that. Now all I'm going to do is come to my wheel. Remember, your cams aren't connected, so it's real easy to turn. And I'm going to turn the motor, and as I do, I see that gauge start to go down. So that piston is on the downward trend. Now if I go the other way, I'm going to keep, and the numbers on the gauge don't matter at this point. You just want to turn until the dial stops moving. Because what the piston has is dwell. In other words, it gets to top dead center, and the crank continues to turn while the piston sits there, and then the piston will start to go down. And that time it's sitting at the top dead center position is called dwell. And what we want to find is the middle of that dwell. And that's true top dead center. So I'm going to turn this until that needle stops moving. Right there. Okay. And now I look down here on my wheel, and I'm at 4 degrees. So now I'm going to do the same thing in the other direction. Now I'm looking for that needle to start to drop. It just started to drop, and I'm at 1. So I was at 4 as it came up to top dead center, and 1 as it came down from top dead center. So all you do is you take the difference of those, which is 3, cut that in half. That's 1.5. So doing the math, my top dead center on my wheel is really happening at 2.5 degrees, according to where my wire is set up. So now I'm just going to move this wheel to 2.5 degrees, right there, and now I'm right in the middle of the dwell. I'm right at top dead center, and that's how you determine true top dead center of your motor. We need that to go to the next step. And we're going to do the same thing with the camshafts because they have dwell as well. Hey, before we move on, 2.5 degrees is where top dead center fell. What I forgot to tell you guys was you got to now move this wire to reset it at 0. There. What do you think, Cam? Good? Mm-hmm. Cool. Cam says we're good. We must be good. All right, let's. Hey, Cam, let's do the cams.
By the way, guys, I'm the cameraman when it's not held by something else.
Yeah, you probably do a better job than up there, actually. Step 3. So I've moved my little dial gauge up here, and I'm on the number 4 piston. I got this clamped down, it's not going anywhere. Got a little pressure on my gauge so it can move up or down. And so we want to set crank for, I'm going to do 105 on the intake. Not, 104 is a good rule of thumb. I'm going to go for a little less overlap because I'm looking for some more low-end torque. So I'm going to go probably 105 on the intake, 109 on the exhaust. But you can do 104, 104, no worries. Here's how you do it. It's pretty easy. So put the belt back on the cams, tighten it down so the belt's nice and tight. You want it not set to the standard tension, but you want it super tight so nothing moves. And then we're going to rotate the motor back to 105 degrees. So let me get the belt on, and then we'll pick up from there. All right, I got the belt on. I'm at top dead center. And remember, I set these up so if these were 104 pulleys, the green dots would be right here. Now, a lot of guys will put the 104s on there, line up the dots, take them off, and then switch on the verniers. You can do that too. I just lined them up prior to putting them on. Okay, so I got that set. What I want to do now is rotate the engine clockwise. Take that gauge up for a second. So I'm going to go to, because I'm timing the intake, I'm going to go to 104 on the intake wheel. I'm setting at 105. So I'm going to 105 on the degree wheel. Now this wheel is nice because it gives you a red range here. And that's 100 to 120, and that's generally where all intake cams are going to be set. So you know you're in the right vicinity when you're pointing in that direction. All right, so that's set at 105. Just going to come over here on the number 4 cylinder. You get my gauge down in here. All right, now it's setting on the top of the tapping, on top of the cam follower. So now here's the trick. This is where vernier calipers really let you dial in a motor. I'm going to loosen up the screws on the vernier caliper now. They don't have to come all the way out, but just get them loose enough so they're not grabbing. All right, so now, timing this, I'm looking for my other socket. Is it under your feet? Hey helper, where's my socket?
I don't know. What do you use a socket? Does it look like that?
I found it. This is a socket. All right, just like we did for top dead center on the piston, I'm going to rotate the cam. So when I rotate the cam, the belt doesn't move, right? Camshaft is moving independent of the whole system. That lets me dial in the camshaft exactly where I want it. So I'm set at 105, so all I have to do is find the middle of the dwell for that particular cylinder, and I know I'm exactly at 105. So same thing with the piston. I'm going to move until it stops, the dial stops moving, coming up on full opening. All right, right there, the needle stopped moving. So what I'm going to do now is look at the vernier gauge on the cam wheel and know where my marks are. So, and I just go for one side, just like I was working with one needle here. So I'm basically a half a degree in. Now I'm going to keep turning to see where it starts to close. So right there it starts to fall a little bit, and I'm about 1.2 degrees. So I was a half degree where it was fully open, and then 1.2 when it was starting to close again. So what you want to do is find the middle of that. So I got 1.2 plus a half, so that's 1.7, half of 1.7.85. I wanted 0.85 in between the two, so I'm just going to move this back 0.85 to the middle of that dwell, and that is the middle of the dwell for that particular, for the cam. So now I know that my full maximum opening point, because I set it right here at 105, I know my maximum opening point is exactly 105, and my camshaft is exactly at top dead center. So that's kind of it. You know, there's a lot you can read. It talks through a lot of the details, and I know it's hard to see some of the vernier gauges on these, and you probably couldn't read the dial. But that's the general process, and I hope that helped a little bit, because I think that, seeing someone do it combined with then going online and reading through some of the instructions makes a whole lot more sense than if you're just trying to read it, or you're trying to do it with, you know, not having a good idea of what you're doing. So intake's done. Last thing we're going to do is the exhaust. Hey, one more thing before we go to exhaust. I almost forgot to mention it. Most important part: when you get your cam set where you want it, make sure you lock down the screws for the vernier. Otherwise, you're going to hate yourself and have to start all over again. So I'm going to go lock these suckers down, and then we'll move on to the exhaust. Motor's at top dead center. Degree wheels on the crankshaft. I've got my little pointer here, makeshift pointer, facing the top dead center. That's top dead center we determined through the dwell of the #1 piston. And we've set the intake. Now we're going to set the exhaust. So I'm going to set my exhaust to 109 before top dead center. So first thing I'm going to do is just turn the you turn the crank with your degree wheel, and you want to go to 109 before top dead center for exhaust. And this wheel's great. It gives you the red area for intake, the white for exhaust, generally where cams are timed, so you know exactly where to turn to. I'm just cranking the motor over clockwise. Here's bottom dead center, right there. Coming up on the exhaust center line of the load, which is full opening. So I want to set this to 109. There, all right. So we got that set to 109 degrees. So now we need to find the dwell on the camshaft, because in the #1 piston right now, the camshaft lobes on the exhaust have those cam followers fully depressed, so the valves are fully open on the inside. What I want to do is find the absolute center of the dwell on that cam. So I'm just going to loosen up the vernier. I found that I do want to keep tension on the cam belt. I'm not going to loosen the tension. I can loosen the wheels on my vernier, or the bolts on my vernier, and the wheel will turn for me without the belt turning. So I don't know, for me I just feel like it's less likely to slip or get out of time on the intake. Alright, so now I could turn this camshaft independent of the whole system. And I'm looking for the dwell. I'm using a dial indicator, and this is down on riding on top of the cam follower. I just want to find where the top of that cam is. So I got to reposition my dial here. It's not acting nicely. Okay, that should do the trick. So I'm going to back off. I see that needle falling. That means I'm coming off of the valves being fully open. So now I'm going to slowly open those valves. And I don't know if you can see, but that needle's moving. When that needle stops moving, that means they're fully open. So right there, it has stopped. So now I'm going to keep going and see where it falls. And I'm going to note the vernier gauge On the cam wheel here, you want to note where that is. So, and it's not numbered. You just have some lines to work with. You know, I come from one side. I know it's not going to make sense, but I'm like at 1.2 is what I'm seeing here. But you just need to find a measuring system that works for you. So, because what we're going to do is find the middle of the two measurements we get. So that's the first one. I'm going to keep going until I get past the dwell. I'm going to keep going. And right there it begins to fall. So on my wheel, I've got about a degree between when it's fully opened and when it starts to close, and that's the dwell on the camshaft. So I just want to take this vernier camshaft wheel now and go back half the distance. So I went back a half a degree on the wheel, and now I know I'm in the middle of the dwell on the camshaft. So my 109 timing that I set down here on my my crank dial is really dialed in to exactly maximum opening point, the center of the dwell of the maximum opening point from my valves on the exhaust stroke. So that's what it's all about. You know, it's a little weird at first, right? You got to do it a couple times to get a feel for what it is you're actually doing, and what measurements and results you can expect. But once you get the hang of it, it's really quite simple, and it's a great way to fine-tune your motor. I wouldn't want to do this in the car. I don't even know how I would do this in the car, because I wouldn't be able to see the vernier scales, and I wouldn't be able to see the dial wheel. So, you know, this might be a one and done type scenario. So I hope the motor runs good, 105 intake, 109 exhaust, because if not, it's going to be a challenge to change it. But there you go. I hope that made a little bit of sense. Button up the front of this motor and get this thing back in the car. So I went ahead and I moved that back to 109 on the exhaust. And then I came up here to the vernier caliper and found the center of the dwell, and then locked down the vernier caliper here after I did that. And you couldn't see it in the video before, but if I zoom in here a little bit, you see there the lines you have to help measure the degree on this vernier wheel. And so the silver portion of the wheel is turning when you turn the camshaft. The black portion is not, because it's attached to the belt. And I just look at the first dot, and that dot's going to move from like here to there, you know, on your maximum opening point of your camshaft. So I just find those two locations and then just come back right in the middle of the two. So that's all I was doing with measuring the camshaft.